So following on from the previous video, we got to this stage here where we were trying to understand this. We were trying to understand this first step here. So when you take the dot product of a constant vector, it will be some sort of constant squared. So we looked at this scenario here. And it works for this case and this case. I want to illustrate the same thing but from a different perspective. So let's look at it in this way. So us trying to understand this. So us trying to understand this is the same as us trying to understand this. Is the same as us trying to understand this. So let's say you've got some sort of vector here from here to here is r. So the x component, the y component, x component, y component. So this r here is this, and when you take the dot product, it would be this times this. That's this thing here, plus this times this. That's this thing here. So so looking at this, taking the dot product will give us this thing here. But then if you look at this here, so if you look at this is like you squaring the x component. That's this bit here. Hang on, that's this bit here. So you squaring the x component, and then you squaring the y component. That's this bit here. So this is a bit like Pythagoras here. And then so the left hand side is this thing here, and then the right hand side, the magnitude. What is the magnitude? Well, the magnitude is the hypotenuse. So the magnitude is the hypotenuse, and then you square it. So if you look at this, well, what is the magnitude? The magnitude would be u. Remember, this thing here is this thing. So now let's look at it from the right hand side. The right hand side, get the magnitude. Well, the magnitude would be r1 squared plus r2 squared, and then square root the whole thing. That is the magnitude. And then you square it, So these two will cancel out, giving you r1 squared plus r2 squared, which is the same as the left hand side. So so you can see, well, when you take the dot product, it's a bit like you using Pythagoras. So the left hand side is this thing here, so that's this area here, and then the right hand side, get the magnitude squared. Well, this is the magnitude, square it. So it's just you using Pythagoras. So let me illustrate it. So we're trying to understand this thing here. So let's look at this famous triangle 3, 4, 5. The vector here is this thing here. So the vector is 4 across, 3 up, 4 across, 3 up. And then when you take the dot product, that would be this times this plus this times this. That would be 25. And then if you look at it from the right hand side, the magnitude is 5, and then you square it, so that would be 25 as well. So the right hand side is 25, the left hand side is 25. So that's another way of looking at it. But going back to our scenario, going back to our plane scenario, right there. So this is our plane flying about, and then this is our unit vector. It's changing as the plane is flying through 3D space, and this is a tangent. You see, you trying to understand this bit here. When you take the dot product, when they're of equal magnitude, you can say it equals some sort of constant squared. So that means it's this. You can say it here because no matter where so the plane is flying about in 3D space. No matter where it is, the unit vector is always of equal length. So you can say that when you take the dot product, the radius will always be the same. The radius will always be the same. But then if you look at the tangent, remember the tangent is this thing here. So if the plane is here, the tangent is really long. It's really long. If it's here, it's really short. You see if you look at the dot product of this scenario here, you can't say that the radius is always of the same length. So we are trying to understand this dot product of one vector with another vector equals some sort of constant squared. It works for this case because the radius is always the same. The radius is always the same. Whereas here, if you look at a tangent, you can't say it equals some sort of constant because the radius is always changing. 1 minute, the radius is long. You see, when it's of a constant length, then you can say this, it equals some sort of constant squared. Well, you can't, the same can't be said for the tangent, because the radius is always changing. So I hope you, so we are trying to understand this thing here. I hope you can accept the first step. I hope you can accept this step. Okay, so we need to understand the rest, but hopefully you can accept the first step. Okay.